Hello everyone, good afternoon and welcome back to IIPD Global. And in this video, we will see how to configure the Allen Bradley MicroLogix PLC, specifically the MicroLogix 1400 for Modbus 485 communication. Okay, so in the previous video, we saw how to configure the Modbus TCP. So in this video, we will see the RS485 communication. So before starting that, the programming for RS485 is also very similar to that of Modbus TCP. The only difference is the configuration of the hardware, and we will see how to read single registers, multiple registers, read and write single and multiple registers as well. Okay, so in the coming video, so in the first video we will see how to set up the module for RS485 and read and write a value to a single device. Okay, so let's start. So for that, let's open a new project. So let's say file, new. I'm having the 1400 series B. Okay, so in the control properties, let me set up which is the PLC. Yes, and apply. Okay, so on the channel configuration, I will just set up the IP address since I'm using Ethernet to communicate. Okay, so apply. 92.168.4.255.255.0. Okay, so in the MicroLogix 1400 PLC, we have two communication ports. Let's say three communication ports. So let me give an example. So if you see here, so the PLC will have a communication port here. Okay, so communication port 1, this is the channel 0. Okay, and this is channel 2, and we have this is channel 1, that is the Ethernet port. In today's video, we will use the channel 2 for our communication, because to use this channel for RS485, this channel has an inbuilt RS485 port which can be directly wired. So you need a special converter for that. So the Allen Bradley, let me show you the model. RS485 cable for Logix PLC. Yes, you need this converter cable. So specifically, yeah, this one. Let's say this one. You will need this converter cable. So this is just a cable which splits the 8 cables into multiple things. It doesn't do any conversion. It's a 8-pin to RS485 pin connector. Okay. So it's available in Amazon. You can buy it from anywhere, online, wherever it is available, or you can use a very cheap adapter like this. I bought this off Amazon for around $15, $10 to $15. So DTech is a Chinese brand, but it is good. So I use this to convert the normal RS232 port here into an RS485 port. That is how we are going to use this. Okay. So let's see how to do this. Okay. So let's configure the port for the communication first of all. Let's minimize this. So we have to go to the channel configuration. So this is channel 0, the one I was talking about, the 8-pin connector. This is channel 2. So this is the one that we are going to use. So the driver, I have to set it as Modbus RTU Master. So the communication I will use as similar to the device we are going to read. So we will be reading this. Let's say temperature controller. We will read this temperature value and write the set point. This is what we will try to do today. Okay, this device is already pre-configured for 9600 baud rate. So none parity, 1 stop bit and 8 data bits. So 8 none 1. So that is the configuration that I have configured in that module as well. Okay, no handshaking, nothing else to change here. Apply it and give OK. So now we need to configure the system. So to understand what is the address, we need to have, let's say we need to have the value from the device to be read. So for that we need the address registers. So the device I have is the Atronix TK for us. So let's say I want the Modbus address list. So you can get it from from any online source. Yes, this is the same device. So I want to read the current value. I want to read the input register value. So let me just maybe download this so we can open it in Adobe Reader. So it's downloaded. Let's open it. Sorry, okay. So you find it. Yes. So we need to know the present temperature value. So that is mentioned in this address. So that is a present value. So the address is 301001. This is the register we need to read for to know the understanding of the address. Okay, so understanding the current temperature value. So let's minimize this. So let's see. So for that, just put a no contact. Let's say I want to use a binary tutor B3:0/0, just a binary value. Then so we will use the message instruction like the Modbus TCP. So input message. So we need a message file. So let's create the data file 9 new. So 9 we need the message file. So let's say message. Okay, so we don't need to do anything else. Okay, so we got the message file mg9. So we will use this address to the message file. Close it. So now we have to go into the setup screen. Let's go into the setup screen. So here we need to set up first of all which channel we are trying to read. In Modbus TCP we would have selected integral Modbus TCP. So if you are going to use the integral Modbus, you will use number 0. Okay, so we will use 2 here because we are using the so you remember that we configured here channel number 2 as our Modbus. So let's set up that. So integral 2. Okay, now you can see it is asking what type of data to read. I want to read a holding register. So that is a 3 series register. So if you see here, you can see this is a 3 series registers 301001, and it is asking for to where it needs to store the value. So N7:0. I'm just giving there, and I'm trying to read only one data register. Okay, I'm trying to read only one data register. Then it is asking them MB data address and the slave node. So the MB data address, see now it's 3001. So as you remember that if the second digit from the left is 0, you can ignore that. So what is my address here? 1001. I just need to give the last 4 digits here. So here I'll give 1001, and the slave node address will be 3. My temperature controller is configured at the address 3. Okay, so now that's it, 31001, and I'll just close this, save this, just save it randomly in one location, compile it, they'll just download it. Yes, going to run mode. So now let me open the N7 register here. So as of now the value is 0. As of now you can see the value is 0. I want to trigger this. Let me just put it like this. So you can see the temperature value here. And here let's try to show the entire thing. So it's very small. Let it be big. It's not a problem. So whenever I trigger this instruction, when I toggle this, you can see I got the value 25. So now you can see this is the temperature sensor. So I'm holding this. You can see that it becomes 26 now, but here it is not changing because I need to request the value again. So it's 27 now. So 28 there, but it's still 27. So I will again read it like so 28 now. So again if I trigger it, it will become 30. So again, so every time I have to trigger it. So to avoid this, what I can do, I can change this into a sequential value. That is, I can give a time base here, that is S:4/12, so which is approximately half a second time base. Okay, so I can download this again once more. So I will download fully. Now you can see it is blinking here, meaning that it is automatically reading it continuously. So if I open N7 again, It's now 32. So if you open the camera as well on the side, so it's 32 now. So I'm just holding the sensor again. I'm just holding the sensor again in my hand. So you can see here it's 33. It's immediately 33 here. So because the data is getting pulled continuously, so it's 34 here, it's 34 here immediately. So every half a second this will read the data. So you have to remember one thing. A Modbus is a request and acknowledge protocol. So when you are having more than one device to read data from, then you have to think about the round trip time. So for example, it has to request data from each device. So it will take time. So half a second for this device. So let's say you have 20 devices. So it takes 10 seconds completely to read all the 20 devices for once. So you have to remember that while you are doing the Modbus programming. So it's 37 now. So now we will see how to write the value. I want to send a value to this preset. I want to send a value to this preset. Now we saw how to read the value. Now you will try to write the value into the system. So what I will do, I will go here. Let me just go offline. So then what I will do, I will create one more message instruction, but with a new address 1. Okay. Let me just zoom it a bit more so it will be easy for us. So here what I will do, I will just put one more NC contact with the same address. So it will alternate. So like in Modbus TCP, we need to alternate it between the first and second. We need to alternate it between the first and second. Remember this. Okay. Now you can see here. So we have the 2 blocks. Go to the setup screen here. So we need to go to find where to write the set point. So the set point has to be returned to this address 40001, which is the set value, which can be returned from I think 0 to 1000 or 1299, something like that. So I need to write the value to this address. So I'll go here and I'll go here and same thing. So this is 9.1. So let's go to integral. Again, I'll change to write single register. I don't want to write multiple registers. I'm just going to write a single register. So data table address, I will give the, let's say N7:1. So the next address, and the slave address will be same 3, and the immediate address will be 1. So 4001. As I said, the second digit from the left, if it is 0, it can be neglected. So 4001, it can work. Okay. So next, I'll close this. I will download this. Okay. Then I will see here. So now you can see this is continuously happening. So let me just put it like this so that we can see both together. And the N7, you can see here now it is 1 here, 0 now, so it's 31 here. So I'm just changing this value. So let's say I want 25 degrees. So you can see immediately the value 25 gets written into the system. So let's say 30 gets written, 75 gets written. Let's say I want 65 gets written. Let's say I want 1000. So 1000 won't get written, 999. Okay, 1000 got written. Let's say 555, 52. So 552 it got written. So every half a second the value will be written into the system. So this is how we read and write a single register in Allen Bradley's MicroLogix 1400 PLC. In the next video we will see how to read 2 devices simultaneously and multiple reading registers, and I will also show you how to read a double word or a floating point register in MicroLogix from a multifunction meter that I have, and process the data to give the proper value. Okay. See you in the next video. Thank you.